we're going to create the corridor designs. We want to have some control over what happens later on. So let's go to the control node and create a couple of extra parameters. For the options I need a new float, then toggles, and finally one color picker. The float value will be my design seed. This value will influence which design a corridor is going to. The first toggle will be used to choose one design per corridor. Without it, a corridor wall uses the corridor ID. When it's activated, it will use the shared corridor ID. The second toggle will decide if one corridor chooses either both walls have independent colors or the same to have a matching look. The third toggle will decide if the whole scene uses one main color for all the designs. If the main color is selected, we of course also need a main color that we provide. For now we let the toggles deactivated, but for the color picker choose any color so that we can check if the value transferred works. Copy one of the parameters, we will need it soon enough. And now it's time to create the design subnetwork. Start with a null, this is the ingoing node, connect our already marked areas to it and then make it a network. In here we will handle all the corridor related tasks. So and before we start, let's prepare the network. This will be quite a big one. We will have an area that handles the floors, then another one for the ceiling, and for the sides we need to choose a design. An attribute wrangle, and first we bring in some of the control parameters. We need the seed and the toggle for the shared design. The result will be saved in a float variable called chance. Create the UI elements and paste the relative reference. The parameters in question were called design seed and shared. Now the idea is pretty simple. If the toggle shared, we want to get a random value using the seed and the shared corridor ID. If it's not enabled, we'll create the chance value with the seed and the corridor ID. That way the shared version will have the same result sides of the corridor. As part of the course, I will provide you with 6 different variations how the corridors could be designed. The ID and names for those designs are 1 for the pipes, 2 for the windows, 3 for the 3 designs where I provide a prepared panel with the sizes 1, 2 and 4. The design is chosen by the chance. Chance is a value from 0 to run and will be fitted between the possible design IDs. And since we need we have to cast the result of a rin function. And now we should be able to pick one design at a time. Let's test that with another visualizer. Create a new one and call it design. We used primitive attributes to find the chance value. We also need to turn the wrangle over to primitives. And now we get design values. As with the floor and the ceiling, we now can feed this geometry into networks that deal the windows and the cooling variant. For the 3 panel variants, we can take one single way. They will be handled slightly different, but I still want to pass through the corridor walls. So I create a blast node, structure attribute, if the primitive contains indeed a corridor. After we got rid of the gateways, I create another blast node to check for the design values that are higher than 3. Now each corridor side is assigned one design. Might need some preparation before we can go into the details. This area is the right place for that. I don't need to touch the panel variants, but for the pipe and cooling design I need to do some tweaking. So let's start with the pipe variant. Jump in, I also copy the corridor blast node. I could have used that one blast node for all of the variants, but I wanted to have all the nodes contained in their own subnetwork just to keep it organized and independent from each other. The second used to find the panels for the current design. The pipes have the ID 1. Just a quick check with the design visualizer and we're fine. Now for this design I need to find the outer pieces, and we already used a way to do the same method we used to segment the floor and ceiling panels. Turn the wrangle to primitive, and we need an integer array for the points and an int variable for the neighbor. Fill the array with the points of the current. Loop over that array and then grab the neighbor count of each point. As soon as we find a point that only has two neighbors, that primitive gets marked for removal by creating an attribute remove set to 1. Use that attribute with a blast. That gives us access to the outer pieces. At the same time, we can keep working with the remaining primitives by just copying the blast option delete non-selected. Since I already have access to those primitives in the wrangle, let's add another attribute. For those primitives, we set the attribute endPanel with the value of 1. That way we have easier access at a later. Then copy the find outer pieces wrangle and connect it to the remaining primitives. This time set the endPanel attribute to 2. We will not need that for the pipes, but for the cooling. And then copy a node again, this time for the outer pieces. The remaining wall gets even shorter. Now we can merge the first end panels with the remaining wall, and that's the output for the pipe variant preparation. The important task at this stage was to find and make them easily accessible. The approach is very similar for the other two, so let's copy these nodes and head over to the window variant. Now, as I said earlier, I had to do the tweaking for the pipe and the cooling variant. Design, I don't need any end panels, so this subnet can be handled the same as the last 3 designs. I only need the blast for the corridor and the second blast for the design ID. The ID itself has to be set, and now only the cooling variant remains. As I already hinted, in this design I need the outer end panels and then from the remaining parts the new end panels. And the basis for that is already prepared. So paste in, change the design to 3. And it looks like that by accident we have not a single wall with the cooling variant. Let's pin the viewport and go up to our control node. Let's change the design seed until we find an example. There they are. Back into the cooling subnetwork. Now for the cooling variant I need the second end panels. So I copy the blast node and change the condition to the end panel equals 2. I already set that attribute when I was subnetwork. Then I'm going to copy the attribute wrangle node once again to find the new end panels. And this time I only want to find them to really get rid of them. The idea behind that is to have separate designs on. When I'm finished with them, I want to move them one panel towards the middle panels so that the overall design has one empty panel at the outside corners. Let's combine that all into the merge, and there's one false. The result should be the middle panels, one empty space, and the 2 end panels. This one fills the empty space, so let's disconnect that one, and now it should be correct. So let's leave the cooling variant and take a look. We have the pipe variant with one end panel, the window with all primitives still attached, and the cooling variant with 2 end panels. And the last 3 designs are also still complete. And here down in the merge, all are combined again and ready for the details.